Well, hello everyone and welcome back. So in this one, we're going to be looking at debt comparison. So Kaylee's credit card debt is normally distributed with a mean of 5,000, a standard deviation of 1,000. Her debt is 1,500 below the average. Josh's student loan debt is distributed with a mean of 30,000, a standard deviation of 5,000. His debt is 2,000 below the average. Who's in a better position in terms of their respective debts? And so what I mean by better position is better position relative to other people in that same debt class, not who owes less. So it's kind of like the strongest performer kind of thing, but in reverse. All right, so let's frame the problem. Find the probability below x. And so there's our probability function. So Kaylee is going to be one tail left, so is Josh. And then the mean is 5,000 here. It's 30,000 here. Standard deviation is 1,000 here. 5,000 here. X is, okay, so she's 1,500 below the mean. So the mean is 5,000. That means she's at 3,500. And Josh is 2,000 below the mean, so he's at 28,000. All right, let's look at the pictures. So here's Kaylee, here's Josh. So completely different distributions because the scale is very different between them, right? This is student loan debt, this is credit card debt. So the question is, who's better off? Meaning that compared to other people in that same debt class, who's doing better? It's looking pretty good for Kaylee because she's pretty far away in a negative direction from the mean, whereas Josh is kind of really close to the mean itself. But again, harder to see on this graph, though we can get it from the standard deviations. Kaylee's about 1.5 standard deviations, and Josh is like just under a half a standard deviation to the left. But it becomes really clear on this graph where we plot them, we standardize both and plot them together based on their z-scores. And here you see Josh and Kaylee. So Kaylee is in a lower percentile, which is what you want to be when you're talking about debt. You don't want to be the person up here that owes more money than everybody else. So let's look at the z-scores. Is going to be equal to x minus the mean divided by standard deviation. And you're probably wondering, why do we make you do this? Because you need to know how to do this, even though they're magically appearing on the graph, because we have lots of logic behind the scenes that makes these graphs. But you need to know these functions. This is just a nice way to check your work. All right, and then Josh is going to be, I think I can just copy the function. And the probability is norm.s.dist. This one's to the left, so I shouldn't have to do the whole subtract from one thing. And you can see that Kaylee's in a lower percentile, which is where you want to be with debt, than Josh. So who's in a better position? It's Kaylee, because she's in a lower percentile. Not because her debt is lower, because she actually, that's not the reason, right? You might say, well, she owes less money, so that's better too. But the real reason is that, relative to the type of debt she has and other people that hold that kind of debt, she's in a better position than Josh is relative to the type of debt that he's holding with the student loan debt. And then you have some questions that you need to answer, and that's it for this one.